Hello community! Today we talk about Speculative RAG, and it is a brand new research by University of California, Google Cloud AI Research, Google DeepMind, and Google Cloud AI. My goodness, all these beautiful companies, July 11, 2024. And of course, we are finally talking about RAG again. So what is the latest, most advanced RAG system you can do? Now, easy. Here we have the pseudocode, and this is really a beautiful structure. Now have a look, because let's say, wait a minute. Before we do this, do you know that there's now this statement that RAG, you know, this beautiful RAG approach with the vector similarity, the vector store, the vector database, the search technique, the re-ranking, this is what we call now a baseline RAG system. And you know, RAG we have because if there are data like business documents that the LLM has not been pre-trained or fine-tuned on, then we have RAG system. Now, as it turns out, as we observe now, baseline RAG performs now very poorly. And you might say, who dares to say that? RAG, this is our beauty. This is our child. Who dares to say that RAG performs... Oh, okay, this is by Microsoft Research. Okay, good. So this is now a little kind of a surprise. So RAG performs very poorly. So what do we do? You say, Microsoft has now a new thing. It's called GraphRAG. Now I know what you mean. So just 16 hours ago, the GraphRAG has been updated and beautiful. We have now new possibilities in GraphRAG. And if we look at now GraphRAG versus compared to this old baseline RAG, we have now that baseline RAG struggles to connect the dots. This happens when answering a question requiring traversing disparate pieces of information through their shared attributes in order to provide new synthesized insight. So RAG fails to connect the dots. My goodness, I was paying here Microsoft Azure here now for almost a year for their RAG service, and now they tell me this. And Microsoft goes on and says baseline RAG performs poorly when asked to holistically understand summarized semantic concepts over large data collection, or, and now this is a bummer, even singular large documents. So RAG does not even understand a single large document, cannot have a summarized semantic concept. And yeah, here it is, Microsoft GitHub IO GraphRAG. And this is quite a beautiful statement, no? So community, here we are now, and yes, officially we have to announce that RAG unfortunately has been declared ineffective by Microsoft. And you say, but wait a second, because here Jerry's just yesterday posted here on some platform. It says, you know, there's a lot of hype and debate around GraphRAG. And I've said it before that GraphRAG makes sense if you model it as a superset of RAG. And you say, wait a minute, what do you mean with a superset of RAG system? And he goes on and says, you can still keep the vector search, you can keep your vector store, you can keep your vector database that you pay thousands of dollars if you're a company to the commercial vector store provider. And you might say, my goodness, okay, so I can keep paying here, for example, here Microsoft for the vector store functionality and everything else. And then on top, we use graphs to augment the context the model has to make a decision. Plus, Jerry tells us, you know what, graphs are cool to visualize. And now we go here to the CEO of Neo4j and have a look. And I think this is nice because it tells us, hey, what is GraphRAG? And it's one image. Simple. GraphRAG is RAG, where the retrieval path now includes a knowledge graph. So you see, where we normally had all the vectors embedding of our features here, now we have in our vector store all the beautiful vector embeddings plus a knowledge graph. This is it. July 11th, and you say, hey, great. But then I started to think and I said, but wait a minute. So I have an expensive vector store, a commercial product if I'm an enterprise, where I have encoded all the semantic information of all my business documents, hundreds and thousands of documents, in a vector embedding that is computed here by a sentence bird or even maybe it's an autoregressive model. And now I need, in addition, to pay for a graph representation of the same semantic data, of the same identical business files, so that I can go now from a baseline RAG, which according to Microsoft has only a very poor performance, to a more expensive GraphRAG structure on Azure. And suddenly I had a feeling that I know why this is happening, And I said, oh, I understand. And here we have more information about the explosion of research articles in the last month, how we integrate knowledge graph in RAG system. And it turns out that building a knowledge graph of your data, of your external data, and using it in RAG gives you several powerful advantages. So now here the CEO of a graph company tells you, hey, graphs are good for RAG. And he says it gives you a better answer to most, if not all of your question you might ask an LLM using just the normal vector-only RAG. And this alone will be a huge driver of GraphRAG adoption. In addition, it continues, once you've created your knowledge graph of your 10,000 documents, you got an easier development thanks to data being visible when building your app. And the third advantage is that graphs can readily understood and reasoned upon by humans as well as machines. So I'm so sorry to tell you, now we have to deal not just with vector store in our advanced RAG system and retrieval and multi-re-ranking and multi-I don't know what. Now we can integrate here also our graph structure in our RAG system. And he gives us 3 good reasons, and the first reason is here. There's some beautiful research, and LinkedIn published a study and everything, and a knowledge graph improved the accuracy of LLM responses by 54, and now, careful, 0.2%, and this is an average of 3 times. So 3 times. Okay, second is improved data understanding. And an engineer told him that a very sophisticated AI fintech company, that they ported an application from RAG to GraphRAG, and they immediately found several bugs, thanks now to the visual nature of the graph that human can read and understand. Of course, the bug is still here in the vector representation, so never mind. And third, isn't it beautiful? We have now explainable AI, because we can read now all the relation and the correlation between our nodes. And imagine, we can now explain our customer what is going on in the AI. We have an explainable AI system that we can say, hey, we have a glimpse of an idea to know what theoretically could go on and why we get this performance. So here we are, RAG, old classical darling, has been now deleted by Microsoft. And long live GraphRAG, so you can pay now for multiple services on Microsoft Azure. After this GraphRAG, we can go back to something that is really beautiful. And here we have it, our standard RAG, our self-reflective RAG, and our corrective RAG. And if you want here, that 8 months ago I did a beautiful video on self-RAG, a self-reflective AI system. But it's all history. Because now we have speculative RAG. We have now a complete new technology. So let's have a look. And you're not going to believe it. This speculative RAG, if we analyze it here in absolute detail, we find out that the RAG process here has 2 distinct steps. At first, we have a draft generation, and the second, we have a draft verification phase. So, first step, we use here a smaller, more specialized LLM to produce multiple drafts from a subset of the retrieved documents. We do this to enhance the diversity of the text and reduce here the redundancy. And then In the second step, we have a larger general LLM to evaluate all these synthetically generated drafts and select the most accurate response based on this verification process. That's it. That's speculative RAG. If you compare it now to existing techniques, you see here, well, of course, since we only have a subset, we have a reduced input token count per draft, but of course, in total, we have much more. We are focusing on diversified subset of information in our data stream, but of course, we have now a massive parallel data stream, and we have parallel processing of drafts. Beautiful. Now here I show you speculative retrieval-augmented generation, the last here in the development of a technology. So we have here a general huge LLM, gets a query, says, I have no idea how to solve this, sends it off to specialist, we call those specialist RAG drafter. They now go, they split up the 1,000 documents here in little pieces, and then they generate from those pieces multiple drafts. And in each draft, there's a different view on this piece of text. And this is generated, and we have parameter, we have the drafts, we have rationals. Of course, the RAG drafter as an LLM understands here the multiple perspectives here in the documentation. Of course, what else? And then after all this draft, is now this avalanche of new views and new rationale here. This multiple perspective mountain is coming back now to our generalist LLM, and he is just evaluating each and every of those pieces of information and just selects the best one. What could be easier than those speculative RAG system by Google? And you understand, yes, of course, because it has to be fast, it has to be cheap, and it has to be good. Okay, so let me come back to the methodology we're going to analyze now. We do this in a very complex matter I call 1, 2, 3. First, document clustering and sampling. So the documents that we're going to examine in our RAG system, let's say 1,000 documents, are now to be clustered based on a similar content. And a representative document from each cluster is chosen to reduce the redundancy and enhance the perspective diversity. Now, you might say, okay, who chooses now from the cluster here the most representative document, because we are not aware here of the complex multidisciplinary interlink maybe of the task at hand? Well, this is a detailed question that you have. Then we have a parallel draft generation. So multiple drafts are now generated in parallel by our specialized little LM, each based on a distinct document subset. So we have now an extreme permutation. If you think about 100,000 different drafts, now you start to permutate this. And then you generate this here in a specialized parallel process, and you get here a quick generation and a comprehensive coverage of all the possible answers there are. And luckily you are Google, because otherwise you would not have the computer infrastructure for this. And then after you have done this, you have a generalist, a huge large language model, but will evaluate each single particular draft against a given rationale, using now a particular scoring system based on our probability densities in the LLM, ensuring that the selection of the most accurate and contextual appropriate draft is done by the system. You see, as easy as 1, 2, 3. What could go wrong, you might ask? Well, absolutely right. So for the algorithm, we use something that we know. We use here a combination of a k-means clustering for the document sorting and, you got it, a probabilistic scoring for the draft verification. That's all that there is. We just combined this, and Google did it, and they said, hey, if we run this on our extended computer infrastructure, we show significant improvements in both accuracy and speed over the traditional RAG system, inclusive the self-RAG system. And here I have the result. And if you look here at the standard RAG on particular benchmarks, and we have here Mistral 7B, and then we have a Mixtral 8x7B, and then we have the self-reflective RAG and the corrective RAG. And you see here they go up if you use Mistral 7B a little bit from Mistral 7b, we have here Mistral instruct. Yeah, let's go with this one, 67. We go now up to 64. Okay. And then our speculative RAG comes in now. And if we use here different version here for the drafter LLM and then for here the verifier LLM for the big one, you see here the best is of course if we have for the verifier, for the logical one that does all the probability analysis, we have here at 8 times 7b our Mistral model, but for the drafter of course we only need a little Mistral 7b free trainable parameters, and if we do this combination we have here, as you can see, the best performance overall. Congratulations to these results, particularly selected by your preferred Google team. Now, give you an idea about the prompting and the drafts that are generated. So here some very simple visualizations here from the annex of this research publication. And they state, hey, we run here our M drafter over the M document subsets and produce corresponding answer drafts. We incorporate each document subset into the prompt and query now the drafter for responses. So we obtain M drafts as the answer candidates, and each draft is grounded based on multiple perspectives in the retrieval results. And as you can see here, for example, here you have a rationale for this particular task and a response for this particular task. Then, if we go on in the process chain, after generating all the drafts and the rationale from the RAG drafter, we evaluate now each and every draft by a generalist LLM. We call it here a model verifier to filter out the less reliable drafts. And this is here simply probabilistic. We select the best answer. And that's it. Now, if we have, as I told you, multiple views, so we get multiple parallel answers to the same task, I will show you here the instruction which actress starred as a particular person in a particular film with a particular title. And as you see, we have the completion and now the verification. And now the system drafts here a score of this with a self-containment score and a self-reflection score 0.5. But there are also other answers to the same instruction. And now we have here a higher draft score and we have a higher self-reflection score. So this is here an answer that the system will choose that this is probably the correct answer. So let me give you another summary. Speculative RAG by Google. Fast, cheap, better than what we have, and yeah, computer infrastructure is not really a topic for Google. So what we have? We have a parallel processing, we have a reduced input token count, we have a complexity management that has both edges, up and down, and it is kind of an adaptive system. Let me explain why. So by generating multiple drafts in parallel, the system significantly cuts down the time required to produce an answer if you only have a single machine. What a surprise. And by ensuring that each draft handles only a subset of documents, the number of tokens processed by the system at any one time is reduced, decreasing for this single task now the computational load, but of course in total we have just more simple tasks. Now to the complexity. The model manages complexity by dividing the task up in two different types of action, one for the LLM that is acting as a drafter and one for the LLM that is acting as an evaluator, optimizing each now for specific subtasks within the overall RAG process. But now, since we are generating multiple drafts, multiple views of the same data, of course, the amount of data goes up and has an impact, of course, on the complexity management. Also, on the particular single-viewed response, the complexity can go down. But if you look at the complete workload, it goes up. And the framework is adaptable. It is capable of incorporating improvements in the clustering algorithm. Whenever you have a better clustering algorithm, just put it in. the draft generation techniques. Whenever a better LLM comes along, use this LLM, and the probabilistic scoring system, the methodology for scoring here, your perfect answer. Whenever you get a better scoring system or you have a more complex scoring system that integrates different views or maybe the complete ecosystem, just put in the better system here in this adaptive system. Isn't it beautiful? Now you might say, okay, this was just a speculative RAG, but we did not integrate here the latest insights by Microsoft that we should use here, the GraphRAG system. So I thought, okay, I spent 1 minute. How would I integrate now in the speculative RAG by Google, the new insights by Microsoft that we have to have here a knowledge graph in our GraphRAG speculative RAG plus system. So let's have a look. Let's say I only have 100 PDF documents that I want to integrate via RAG into my LLM. So now let's say those 100 documents have about 2,000 chapters of text. Then I let my system generate here 20,000 different multi-view drafts that are only focusing here on a particular subset, of course, but generating multiple views on this subset of sub-documents. Now, of course, all these 20,000 drafts that are generated are synthetically generated documents. Therefore, let's say only 5,000 of those 20,000 drafts are hallucinated or contain hallucinated information, and therefore the complete draft is, well, yeah, not really usable. So we can check for hallucination, we can have grounded truth, so we can filter this out. Maybe, maybe not. Plus, from these 20,000, we have about 7,000 drafts that contain the identical graph structure if we build now a knowledge graph built on the multi-view text graph subtexts. Great. Therefore, we have 8,000 drafts left, and now, of course, we have to do here the complete knowledge graph representation if we have not done it here when we calculated here the identical graph structure where we have duplex. 8,000 drafts with knowledge graph, and then we have, of course, since we have also to use here the vector store, because otherwise the industry of the vector store would crush and crumble, and yeah, imagine this. So we have now those 8,000 drafts. Also, we have to project now in the vector store and have to calculate the semantic similarity, maybe by a cosine similarity, also in the vector store. So we have here the benefit of our knowledge representation in a knowledge graph structure space. And of course, here we have here a vector space, 1024 dimensional or higher if you go to a more professional system that is correspondingly even more expensive. Beautiful. So what we get back from our vector store, we get now about 3,000 clustered drafts back from the vector store, plus if we look now at the clustered subgraph analysis, we get about, I just have an idea, about 32,000 clustered subgraphs that are topic specific and contain here a causal, let's call it a reasoning chain. So we are left now with about 35,000 clustered sub-elements that are either representation from the vector store and embedding, or are now subgraphs that we have to apply our complete GNN or graph neural network toolkit for analyzing 32,000 subgraphs. To do this, yes, I think currently it is not able to do, but if you think about 4 to 8 B200, the Blackwell 200 NVIDIA GPU, I hope they can be run in parallel now on a future Azure network, and then I will be able to analyze here the content of 100 PDF documents with this brand new and extended version of a speculative RAG by Google, plus the new insights by Microsoft for a GraphRAG system, and plus I have some further ideas, but maybe I should keep this up for a later video. I hope you understood what I wanted to show you, that if global corporations come up with not solution to make the system better, but just to add further elements that you have to pay for by by platforms that are operated by your AI provider. And you have to pay in plus this, and then in plus this, and then you have to pay more for another service level. You know, remember my last video where I showed you simple system performs sometimes much better than the most complex system you can think of. So I think, again, there's a Pareto pattern, a Pareto border, where if you think about performance versus cost versus time, there's a way that you will find your perfect optimized system, your RAG system if you want to use it, for your particular task. And maybe it's not the best way to go with the latest announcement and with the latest products that are maybe just in beta testing here by your global AI corporation. I hope it contains some useful information for you. I hope you enjoyed it a little bit, and it would be great to see you in my next video.